Hi everyone, I'm Duncan Galloway. I'm an astrophysicist here at the School of Physics and Astronomy at Monash University. I'm here with my colleague.
Yes, I'm Ulrik Egede. I'm a particle physicist here at Monash University.
And so we're going to just demonstrate very quickly a Van de Graaff generator, which is this apparatus you'll see before me. And this is a device for demonstrating the effects of static electricity. And so Ulrik's going to tell us about how that works.
Yeah, so it's really a quite cool apparatus, this one here. It basically works by transporting electrons. So we have a small band that moves around here, and what it does is it picks up electrons from the surface down here, exactly as you do when you create static electricity, puts them onto this band here, transfers them up to the top here, where there's a little comb that sits up here that basically takes the electrons off. Then the electrons will distribute themselves on the surface up here, pushing as far away as possible from each other up here.
And there's the same kind of static electricity you'd have when you rub a balloon on your head or something, and you can stick it on the wall.
Exactly the same idea, and it works in the same way that it's the interaction between two different types of material, so like between plastic and wool, for example, that will create the static electricity.
Right. Shall we turn it on and
let's
see
give
what
it a
happens? Go. So it's going to take a little while, very short time to build up the charge there. What would you say the voltage is, the voltage difference?
Voltage here will typically be up to around 50,000 volts. This is really interesting that the same type of machines here were actually used in particle physics for many, many years. For about 50 years, this was the way that we built particle physics accelerators. We could create a huge voltage difference between these two ends here and use that to accelerate particles up that we could then study collisions with. But let's just look at it at a bit lower scale here.
It's probably built up a big charge now, and if I bring this conductor close to it, we're going to see some effects. Okay, so there's a big discharge there, and that's those electrons flowing from this very charged sphere back through the conductor, through my arm, and into the earth connection in the motor there, and back into the earth.
This is exactly the same effect you have in a lightning, actually, that you get a discharge through the air, you create a small plasma that can conduct the electricity.
See, if I wait a little while, we're going to get a very large...
So is it dangerous, tell me?
Say again?
Is it dangerous?
Well, I don't know. That's lightning, isn't it? I mean, that could kill me,
50,000 volts.
50,000 volts?
Well, I'm an experimentalist, so I'll try it out.
Does it hurt?
Hurts a little bit.
A little bit?
So it saps a bit, but nothing more than that, because it's very low current we have here. Not many electrons.
So we have a couple of other bits of apparatus here, very, very technical bits of apparatus. So here's one of them, and we're just going to demonstrate a little bit further the effects of this static electricity.
There you go. You can see that they get out. I'm trying to get close to it with the ball now.
So they're sharing the same charge as the ball.
Exactly.
And so we're going to discharge again and just do one final demonstration. So if you'd like to deploy the...
Yeah. So we've got a bunch of pie plates here. So what do you think will happen when I put these on here? So again, these here are electrically conducting. So what will happen to the electrons here?
Well, I guess they're going to all get charged as well and somehow repel each other, but I'm not exactly sure what's going to happen.
Yeah, well, let's give it a go.
Oh, there we go.
So the top one picks the most charge, and then they fly off one by one. Very cool.
Too quick for me.
So there you go. Thank you very much.
Thanks.